Our next example with fractional exponents, 16 ninths raised to the 3/2 power. And we saw in the last video that a 1/2 power is a square root. In other words, the denominator is the index of a radical. And so we have some kind of square root here. Might it make sense that it is the square root of 16 ninths raised to the 3rd power? Of course, because, let me work through this step by step. This normally would not be necessary. 3/2 is what? It's 1/2 times 3. And if I apply the power rule of exponents, then this is 16 ninths to the 1/2 power raised to the 3rd power. Because when I remove these brackets, I multiply the exponents. So I'm kind of going backwards from what we're accustomed to when using this rule. But this tells us that whatever this is, I'm going to cube it. And so 1/2 power means square root. So I have the square root of 16 ninths raised to the 3rd power. Well, I would normally jump from the first step down to this step, because the denominator tells you the root, or the index of the radical, and the numerator, tells you what power it's raised to. So let's do the square root. We have 4/3. Since the square root of 16 is 4, the square root of 9 is 3. 4/3 raised to the 3rd power would be 64 over 27. So there we go. It would be acceptable to do the following, but probably not the best thing to do. 16 ninths to the 3/2. You could think of it also as 16 ninths to the 3rd power raised to the 1/2. Well, in that case, we'll end up with a lot larger numbers. In this case, we're going to cube the fraction first and then take its square root. And that's going to be a mess. It's going to be a mess because 16 cubed is, I believe, 4,096. 9 cubed is 729. And then we take the square root of those numbers. So it's a mess. It's a mess. That's why I think it would be a lot easier to perform the radical first on our number and then raise to this power. So I think you can clearly see the advantage of that. But this is technically correct. This would equal to 64 over 27. Now let's do a refresher on negative exponents. And a negative exponent, I hope you recall, is the reciprocal of a number raised to the positive exponent. So by this I mean, for example, if you had 2 to the negative 3rd power, then this means 1 over 2 to the positive 3rd power, which would be 1/8. Another example, if I had 2/3 raised to the negative 2 power, then before I apply this exponent, I want to change it to a positive exponent. So whenever you change any exponent, its sign, whether you're going from negative to positive or positive to negative, then you always invert the base, or the number that's being raised to that power. So by changing the negative sign here to positive, this becomes 3/2. I have to invert the fraction. And now it's 3/2 to the 2nd power, which is what? This is going to be 9/4. All right, well, there's not a whole lot difference with the fractional exponents. When you encounter a negative fraction exponent, then probably the wisest thing to do is to first invert your base, change your exponent to positive, and then finish the problem. So I'll give you an example of that here. Here's our example. I have a negative number, negative 27/64 raised to the negative 2/3. Now, I'd like to make a very important point here. This negative and that negative are two entirely different entities. The negative inside here is literally a -1 multiplying this fraction. It's a negative sign. Whereas the negative up there means we have a negative exponent. Being totally different types of negatives, they don't really interact well with each other. They don't, for example, one does not cancel the other. And so please don't ever assume that a negative exponent will cancel with some negative down there. It never works that way. Now, this problem will have the appearance of it working that way, but it has nothing to do with the negatives. What it has to do with is that when we get done, we're going to square. Because the numerator is 2, we're going to square whatever number we're working with here, and then that will come out to be positive. So that's the idea there. Okay, well, then what are we going to do first? I would always change negative exponents to positive exponents. So let's make that a 2/3. And when we do, what happens is we need to invert this fraction. So it becomes negative 64/27. Now notice I didn't put the negative down below. It would have been okay to do that. You know, strictly speaking, if you invert it, it would be positive 64 over negative 27. But the negative sign can go on top, on bottom, it could go to the left. It's just part of this number. So it's my habit, usually I like to write negative numbers on top. But anyway, there's still a negative there because we haven't done anything to remove it. Now, we're going to do what? The denominator 3 means cube root, or third root. So I'm going to take the third root of negative 64 over 27. And when we get done, we're going to square it. So what happens? Here we are with the cube root of a negative number, and those are okay. Recall that the cube root of a negative is a negative because when you inverse that process, a negative raised to a negative raised to an odd power is a negative. So what would it be? The cube root of negative 64 is negative 4. Again, that's because negative 4 raised to the third power, negative 4 times negative 4 times negative 4 is negative 64. Cube root of 27 is 3. So notice how I'm able to apply the cube roots separately to numerator and denominator. That's totally acceptable by all the rules of exponents. And it is the exponent rules which are driving the radicals, or the roots that we're working with. Alright, so cube root is negative 4/3, and then we're going to square that number, and that's what's going to cause this negative to go away. Since we're squaring